Primeiro, gostaria de agradecer para a iMasters pelo espaço. Geralmente, acho que muitos de vocês conhecem Mercado Livre como um lugar de pessoas que vão quebrar as coisas, mas também somos uma empresa de tecnologia. Então, agradecer pela possibilidade de falar um pouquinho disso. Segundo, pedir desculpas, meu nível de português técnico ainda um pouquinho básico, assim que o resto da palestra vai ser em inglês, mas depois posso bater papo um pouquinho só para praticar, se vocês quiserem. Bem, vamos começar. Okay, so why this talk and what do we want to say here? One of the big things we've been seeing as our company started growing was that we had like these two big competing forces. We start getting more money, we start getting more business, we start getting more users, and our business guys start saying, okay guys, you just cannot break things. If you fall in the middle of a Christmas month, that's it, we're losing millions of dollars, our company's getting everything, so you really need to be up all time. That's what I mean with SLA in this case. I mean the uptime. I mean the quality of service and how often is it that our users end up getting what they wanted when they entered our site. This eventually starts clashing with what we developers want. We want to be agile. We want to create new projects, new tools, new ideas. We want to test, experiment, create things. If you want to have a good team, a motivated team, you have to actually innovate all the time to keep your team interested, motivated in your company, and also to be ahead of your competition. There's a lot of guys around there that will be trying to innovate much, much faster than you. So you actually have to stay ahead of them. This will be sort of a history of Mercado Libre in some way. We'll start talking about what I usually call Old World, which was the original Mercado Libre architecture, where I will say we messed up. It wasn't a good architecture, it wasn't going anywhere, and it took us to have to make a really, really difficult decision. Take everything down and rewrite 100% of our code, and this happened in 2007, with already more than 40 million users registered. So it was a pretty big risk to take. Then we'll talk about how we're monitoring all our cloud and how we're handling alarms. What happens when something goes wrong? Because that's something that you usually give for granted, but as your company grows, it's more and more difficult to deal with that stuff. Finally, we'll go a little bit about our newest system. We usually call it Fury. It's an in-house development, and it's meant to actually go from DevOps to NoOps. So let's get started. First, a few numbers of where we are at right now. We're over 400 deploys a day on 650 applications, over 1,000 developers in 8 different development centers. We have people here in Sao Paulo, in Buenos Aires, different cities in Argentina, Uruguay, Chile, Mexico. And these guys are using 10 different programming languages to solve different business needs for different countries, but also for different business units. We have a lot of different things. We have some people doing shipments, e-commerce, payments, you name it. On the demand side, we have 25 million requests a minute, 22,000 virtual machines running in 7 different data centers, and over 700 DBs in 4 different engines. Most of this stuff is running either on our own infrastructure or on some sort of virtual machines that are being used, but always on an architecture that has been developed in-house based on OpenStack. So let's start with the things we did wrong, old world. At first, I'm guessing most of you have the same sort of architecture when you start any development. The user is creating requests. We had a Java-based programming language, so it was a huge jar where we had the entire code base for our entire application, and everything was connecting to a huge DB. This was pretty useful for us at first because, well, you have to access some data. It's in the same database. Someone probably already created some data access objects for it. If you start looking throughout the code, you find a lot of really, really useful tools, and it's pretty simple to understand. So this system was monolithic, meaning one single code base. It was really coupled because people start writing code, and someone says, hey, there's some code here. It's useful. I'm going to use it. We had a single unified SVN repository, so everyone could see pretty easily what everyone else was doing that was good, and going to a single database. One of the best things this had was the simple infrastructure, no overhead, just one request, one database call, going back maybe a couple of database queries, that was it. Another thing that's really traditional in web development nowadays, we had a single QA team. Okay, I'm developing, I have my feature ready, you guys go, test it, let me know if something's wrong, they give me bugs, I fix, they give me bugs, I fix. And this was pretty much a closed system. We created our own services, our own front ends for the user to see. Anything was done by ourselves and only for ourselves. If some of you guys wanted to actually send some items into our databases or something like that, we'd create a single web service specifically for you. But, of course, that means not enough services are exposed to the community. The uptime usually wasn't that good. And the API or web service design wasn't really optimal. Why? Because, let's be honest, if no one around me is telling me to do something better, I just don't. I just do the easiest thing I can to get people off my back, and that's it. At first, this was really nice. Anyone could say, okay, I'll deploy. We had a ton of servers, same code running. Hey, I'm deploying, progressive deployment. Okay. Some people started messing up. So we said, okay, only some people will deploy. Whenever you want, if you're an expert, just put up your hand, you deploy. That started getting problems again. Why? One expert's working on something, he doesn't know the other one's working something different, they start clashing on their code. So we said, okay, only the experts, some experts will do it, but once a week, so that we have really strict policies. Business kept on growing. Developers kept on growing. We got to a place where we were almost 100 developers on a monolithic system, and the amount of time we lost with bugs, the amount of time the users went into our site and found it down, or the amount of really, really huge downtime issues we had took us to a place where we could only do a deployment by all experts together at 3 a.m. on Thursdays, not covered by any freeze. This was, for example, it's December, we're close to Christmas, no one touch anything. But I have to develop, I have to code stuff, I need to get things in production. No, don't touch it, don't touch it, it's working, don't touch it. So, I mean, it was pretty clear this wasn't going anywhere. We had some really big issues at the same time with this huge database thing. And we took a really, really hard decision. Well, I didn't. Some guys upstairs took it, but I stood by it, which was going to ground zero. This meant progressively start rewriting our entire code base with a microservices architecture in mind. We actually migrated also to a different language, to Rails, and we started using some web frameworks that were not that popular at the time, but we thought had some projection. This is basically the sort of microservices-oriented architecture we have at Mercado Libre, where we have different teams working on front ends that will be visible towards the developer. This is usually an HTML that will end up in the user's screen and what the user will use to interact with our site. We had beneath that a set of APIs which would be accessible not only by these front ends, but by our mobile applications, by our CRMs, customer relationship managers or management. Because, for example, let's think about the previous architecture. If we were down, people started calling us to insult us, and even the reps wouldn't have something to see what was going on. Everything would be down. And one of the big parties is the thing you see there on the right, the third-party developers. That's maybe some of you guys who started using our APIs in order to create your own applications or in order to integrate other clients into our platform. So we started actually giving the same APIs we were using to the other people. Our CTO usually calls this eating our own fish, because if our APIs suck, we're the ones getting sick. So it was basically, let's eat the same thing everyone else is eating. A lot of points here. Okay, so one of the big things here was that this enabled multiple technologies and frameworks at the developer's choice to be used in Mercado Libre. We started completely decoupling the code. We had different GitHub repositories. You could access anyone's repository, but at least you had your own repo. That meant also that you could calibrate the sort of policies you were using, the branching models you were using, anything to accommodate the sort of business needs your code or your application had to solve. Each of these databases also had a different application, a different database. Multiple engines for your specific needs, and this also means different policies to handle this database. You might be doing something where the database is not that important, and then anyone can start modifying it at the moment you want, and you don't need really strict policies. Some other guys might need extremely, extremely auditable and complex rules in order to access anything in the database for the sensibility of the data. This also meant pretty complex infrastructure, possible overheads. Let's think you're getting one request to the front ends, from there, request to the APIs, maybe from there to other APIs. That means you have to have a really, really well-performing cloud and environment if you actually want to do this without the user waiting for 10 seconds for a simple screen. And one of the big paradigm or culture shifts was the fact that QA testing, continuous integration, and all of the quality stuff went to each team. You could do your own deployments, you could create your own environments, and you could create your own policies. Once again, this was also meant to create an open platform, meaning an ecosystem where other developers could interact with our applications, with our APIs in the same way our own business units were doing. Probably the most quoted phrase of all technology, with great power comes great responsibility. So they said, okay, guys, you can choose your technology, you can do whatever you want, you can deploy whenever you want, you have your own code base, yay, great. Yeah, but we got a lot of really big responsibilities with that. First of all, we started to being responsible for managing our own resources. Our VMs became our own to create and manipulate. Our DBs and any services, caches, memcache, anything of those things, we had to create, we had to manage. We did have small teams to actually create tools for us to manage these systems without actually needing to have 100% of the know-how of these different softwares. One other big thing, we started getting control over the networking within our cloud. This means we started switching the rules in order to route traffic to our own application. We don't have any more of a single person that's doing the entire networking and routing of the cloud. Of course, we still had to develop our applications, code them 100%, manage our repository, create all of our automated testing, create all our continuous integration systems. And one big thing is the deployment process started being on our hands. And how, you may say, is a coder able to create, to manage the deploys? They said, okay, you know how your application should be built, how your application should be deployed. Okay, just write a bash script for that. And we started creating a sort of interface within our cloud, and each developer for each application would start writing their own bash code to actually build and deploy on any single clean virtual machine that's just been created, his own code. And on the third big part, we were the ones to ensure quality. This meant we had to define uptime also through this sort of bash script writing, where we would actually create different functions to measure whether our service was up or down. They gave us all the tools to actually also monitor the performance of our application and how everything was doing. And the worst part ever, we had to react when that was going wrong. Meaning, if your app's down, it's you. It's not the infrastructure team, it's not architecture, it's no one else. It's you they're going to call at 3 a.m. Some of the tools, I'm not going to go everything we got for this, just saying like, we're going to call you at 3 a.m., but you'll get a lot of pretty cool tools. For example, we got an API to create the applications, manage all of our pools, be them test or production, manage the VMs. That means just create a VM for myself, create a load balancer for my systems. Also creating all of the services. We started getting an API for database as a service. Okay, I want a MySQL, it's going to be huge. That's just an API call away from me. Our own GitHub repositories to create our applications, write all of our tests, and once again, knowing the sort of interface our cloud had, we also included in there some bash scripts to let the system know how it needs to build our application and how it needs to deploy it to a new machine. And one other big part that I've seen a lot of people forgetting about is they also gave us responsibility to they sort of outsourced the concept of alarms and what to do when something goes wrong. So we started coding our own rules to figure out who to call when something is not right. This is basically sort of scheme that no one understands, but should be a pretty good picture of what microservices look like in Mercado Libre, in the concept that you've got a small infrastructure and DBA team that's creating virtual machines and services that are used, for example, by an architecture team that creates more services, for example, databases as a service, key value stores as a service, caches, queues, and all of that stuff is usually used by our front-end developers and by our API developers. I will take it away because I hate this drawing. Just a quick word. This sort of philosophy maybe also went to our mobile application design. A lot of people might say, hey, you're talking about microservices, there's no such a thing in mobile applications. But I think the sort of same philosophy applied. We started getting a lot of different teams working, each one with their own repository, okay? And there they would code one module, which was the actual module they had to give to our application. So for example, you start the Mercado Libre application and you get sort of a home where you see some of the items recommended for you. Okay, that's a team. They'll create this module, and they'll also create a really small test app that only opens this module. But this way, they can actually develop the entire module by themselves without asking anyone anything else, having complete control of how that works. And also, that CI thing, that box over there, means they also get the continuous integration systems to make sure that no one's messing up when they are committing stuff to that repository. When everything's looking good, they're ready to ship a feature. They just switch the version of the module. They give a call to the guys over at main app, and they just import all of the modules into the main application. And we also have an automated build and store deployment system to actually get all of those modules and all of the features that each of those teams has been developing up into production. Of course, the application will be in production. You will get a lot of different bugs because that's what we do. I think a developer, someone was talking about what a definition of a developer could be. I think it's the definition of the guy you can blame when you see a bug. So you're going to have bugs. We're using right now a couple of different commercial systems called Bugsnag and Splunk. And the application will be reporting all of the modules, share some code, and they will all be reporting to these systems all of the crashes. And then depending on the team that created the module, it's the person who will be responsible to fix this. Now, we'll go to the other part of the talk, which means we said a lot about all of the systems we had and the fact that we could monitor, we could measure, and I'll show you a little bit of the tools we are currently using for this stuff. The first tool we started using is called New Relic. It's a commercial tool. It's usually our default system because it comes already prepackaged in all of the VMs we are creating, and it really doesn't need a lot of configuration at first. We have a lot of different aspects there, if you guys want to read everything, but the basic idea is it just starts measuring when you get HTTP errors. So if you're in production and your code starts exploding, you'll get notified of all the different errors you're returning. And the thing I love about it is you just go and you check the stack trace. You don't need to get into a VPN. You don't need to go and find which of the different machines in your pool actually was the one exploding when you got that error. You just go there, you see, okay, I had 500 errors. Okay, let's see the stack trace. That's it. And you can also check what kind of params was sent here, because a lot of times it actually isn't your code's fault, but someone else's who's just sending weird stuff to you. Be it an attack or be it someone who really doesn't know how to use your service. It's really important to figure out this thing about how we really need to monitor the cloud even when we are not deploying. Why? Because other people in our environment are deploying. Okay? Remember, we're using microservices. This means we are consuming a lot of stuff that's being managed by a lot of different people. So it's essential for us to understand quickly when we are failing and why. It's probably, let's be honest, because someone else deployed and someone else is doing something wrong. It's also pretty good for performance metrics. You can see some transaction traces. Let's take a look at, this is some of the dashboards you might see over there. There on the left, you get the time performance metric, and it's also divided between the different things that are taking so long. So that's pretty good to see if it's your code's problem. Like there, you can see a pretty big peak, and that light blue is actually the JVM, so it's your code with a problem. The green stuff, which is an external service that might be taking too long, for example, your acquirer to process a payment is taking too long, I don't know, or your database also in yellow, but that's not a problem here. It's also pretty good to check out deviations. You can also overlay the information from yesterday, from last week, and you can see if like a surge in traffic is authentic or it's actually something weird you should be worrying about. Then we started using a second tool called Datadog. I love this one for the third point, that's real-time analysis. This thing is really fast, it has almost no latency, so you can have your own dashboard created for your application and just check instantly what's going on. And it's pretty good also for aggregating huge amounts of data. Remember, we said 22,000 virtual machines. We're using it a lot for infrastructure monitoring. So this thing is aggregating information of CPU usage, memory usage, disk I/O, still times, a lot of pretty difficult stuff to be measuring and to be unifying in real time to understand what's going on in your entire cloud. But the main reason we're actually using it, it's not because of the things I like, it's for custom metrics. That means, remember we said that it was your own application. It was yours to define what it means to be okay, what it means to be going down, and what it means to be amazingly successful. So it's your metrics to create. Then the idea was for you to start actually sending information of what's going on in your code. How long am I taking to do the most important thing I have to do? How many payments am I getting? How many items am I selling? I don't know, anything you want. It's pretty good to send a lot of different and complex custom metrics to the system. And what you get also is the possibility to send some dimensions in order to filter afterwards, because you don't know what's going to go wrong in production. So this is what a dashboard could look like. And if you look on top, you actually see the different filters that enable you to, in real time, also filter out information and sort of get a bit down to understand what is the exact nature of the sort of requests of the sort of problem you're getting that affect your metric. It's also got a pretty good alarm system where you can actually say, okay, just let me know if I'm 10% below the amount of items that were being sold last week, this day, at this time. So it's also a pretty good source of business-related alarms. Then we have a log collection system. This is, I think everyone, when they are developing, just takes a look at the logs, but once it's in production, something you forget until everything explodes. You can actually go and look at the logs. It was what we did at first, but imagine you have a pool of 100 different machines working. You have no idea where it is that you're getting the errors. So what we did was we created some agents that, well, we didn't create, we sort of adapted some open source stuff, like everyone does, to actually collect all of these logs, send them over to an Elasticsearch. So I'm guessing the guys at Elasticsearch will talk a little bit about how to do this later. And then we got a front-end, Kibana front-end on top of that. That means you can actually go, check out the logs, and filter them, also query them in real time, and check what's going on. Another pretty big thing here is we are getting all of the logs of all of the applications in a single Elasticsearch. We usually use something that was pretty simple. I don't know how we didn't see it before, but it took us quite a few years. The idea to actually create request IDs. That means a client asks for a screen. We create a request ID for this guy, and every single API call we do afterwards will have the same request ID. So you can actually check the logs of every single application that responded to anything having anything to do what this guy is saying. So you can get a pretty good collection of everything that went on in your entire environment. This is one of the metric-related dashboards you can get in Kibana. It's a pretty good thing. I think we've used Kibana for a ton of things lately. Okay, alarms. Really good when you're in a small organization, something goes wrong, okay, just call the developer. What happens when you get 10 developers? Okay, just call the one who knows the most. You get 100 developers. Okay, just call the 3 or 4 guys who should know. You get 1,000 developers. No one knows. No one knows what's going on unless they are the actual ones who create this code and who understand how it works. So we're using a unified handling of events. That means all of what I've said so far, New Relic systems, Datadog systems, this health.sh, that's the bash script I told you about before, where you describe in a bash script if your application is doing good or not. and any code-triggered alarms. I use this a lot for security purposes. So for example, if some request looks really suspicious, okay, I'll keep on with it, but I'll send an alarm to actually take a look at what's going on. All this is sent to a Node.js programmed server that we call event routing. This place is where each team can add their own rules, and these rules will probably check for the alarm type, how important it is, whether it's quiet hours. That means if I'm sleeping, don't bother me because I have a really bad temper, so please just don't. And then it assigns an escalation policy to see how we will deal with this issue. Here you have an example of the sort of rule a team might add, saying, okay, this alarm comes from New Relic. It's been open for more than 10 minutes. It is within office hours, so I'm okay to be bothered. I won't kill anyone. We check which application this is coming from, and we make sure, for example, it's not a beta server. It's not an environment that's only used for testing, for example. And if all of that's going in a certain way, okay, let's assign an escalation policy that belongs to my team. This is then sent over to another commercial service called OpsGenie. And in this place, we actually manage our different teams. So if I have 10 developers, I'll list them in my own team. We set on-call schedules. So for example, this week I'm on call, and anything that happens, just let me know. Next week it's you, next week it's you. Really important thing, if you guys are using something like this, it's important to define also secondaries. That means I'm on call, but if I fail, the next one should be on call. And if everything fails, just call the manager, get us fired, I don't know. But yeah, we're not answering, sorry. The other good thing is that you manage your own contact methods. So there's no need for a single guy to actually have all the telephones of everyone's email. Let's check out if his Twitter account changed, I don't know. You can just switch it yourself. And also manage a little bit of the details of how you want to be contacted. So for example, I might say, okay, send me immediately an email and a push notification into the application. And if after a minute I haven't responded, just send me an SMS. If after 2 minutes I haven't responded, just give me a call. Otherwise, I'm probably sleeping. I've said a lot of stuff, and maybe, hopefully, you guys might have said, that sounds like a lot of work for all developers. That's a lot of stuff. I don't know this stuff. What happens if, hey, someone just contacted me to go into Mercado Libre, but after everything you've said, no, there's no way. It's too complex. It's too difficult. And that was sort of what was happening. I really loved the system we had. It was really flexible, really cool, really powerful, but it was really difficult as well. So we started creating a new platform. It's called Fury. Again, it's an in-house development. There's no way you're saying that, but I was trying to say that it's an evolution from what we call old world into ground zero, and nowadays into Fury. First important thing here is we are still doing microservices. We haven't switched the philosophy, we haven't switched the idea, we've only switched the platform on which we're doing it. It's a full service-oriented system, and the main reason we did this was to get an easier development cycle, easier learning curve for anyone coming into the system. What does this system do? It just basically creates different pre-assembled flavors for all of the popular frameworks that are being used in our company. So you don't actually have to write the definition of a build for a Java system. You don't have to write the definition for a build of a Node.js server. A lot of different things are already solved for you in these pre-assembled flavors. This means less bash scripts to be writing, to be asking the guys over architecture who know how to write bash scripts to help you write. And it also enables some UI configuration. We created a couple of front ends for the developers to actually go, just click a couple of things, and get their own application running. The following point is my personal favorite and the reason I sort of like this system. It's auto-scaling and auto-healing. Before, what we had to do, remember I said you manage your own VMs? That means you get a day with a lot of traffic. It's you who has to actually go and create additional machines. For example, Christmas coming. Okay, let's create double the amount of machines for this. Then you have to go and delete them. So the system's doing this all for you. And it's got auto-healing. That means before, especially if you had sort of a small pool of computing instances, you could get an instance down. Why? Because it just happens. And it was you they'd call just to wake up, go, delete the instance, create a new instance, go back to sleep, insulting everyone around you. So this is done automatically for you. And what sort of technology are we using for this? It's also Docker-based. I won't talk a lot about Docker. It's a really complex system, but I think Papo just mentioned something about this. It's basically a container where you get your application, but also the configurations regarding this application. And the best thing is that it's sort of a packaged environment. That means if I download a container working in production, it's working on my machine. So we are really getting a really smaller gap between development environments and production environments, which used to be a pretty big problem for us. We decided to run on AWS. Well, that's why we're running it, but the idea was getting a hybrid cloud so that we could break out from our own private servers and also use different public clouds. I'm saying AWS there, but it could definitely be a Google Cloud Platform. We'll get those guys to check out some pricing later, but it could definitely happen. One final thing is it's already got continuous integration because everyone kept saying, no, that's way too difficult. There's no way I'm doing continuous integration. So we just created it for you whenever you create an application. This is sort of what one of our dashboards looks like. So you can see you have a lot of different tabs for applications, for scopes, for versioning, for rules, services. We have a lot of more services. I have to actually update this. So services, remember, it's basically I want a memcached. I need a memcache. OK, someone else is creating it and maintaining it for you. I need a database. Someone else is creating it and maintaining it for you. You need a key value store. Nowadays, we're huge on that. OK, someone will create it and maintain it for you, so you don't actually have to go and say, OK, well, how's Cassandra work? Because that's difficult, let's be honest. And also, you have all of the operation systems. Because I don't know if I mentioned this before, but the idea was with our main cloud system, we want to DevOps. Here, we're trying to go to NoOps, meaning that the guys don't have to do anything. But you can still check out all of the logs, all of the metrics, and all of the infrastructure your application is running on, and also create the new deploys and control the way they are going. So what does this look like for a new developer in Mercado Libre? They come in, they get their own nice T-shirt that says Mercado Libre, and they go to create an application. This system, when they create an application, it creates a repository where the code will be left. They create a Jenkins continuous integration server so that no one can say, hey, that's difficult, I'm not doing it. And it creates all of the network infrastructure to actually run this application in a public cloud. Afterwards, we create a scope. This is, for example, we'll create a scope for production, a scope for testing, whatever you want. But this is the point where we actually create an elastic load balancer to actually route the traffic to each of our instances. We create an ASG, or an auto-scaling group, which is the actual container where the instances will be, and we create some instances for you, because otherwise nothing would happen. We initialize all the log systems, all the metric systems. We download the container you just created. It probably says hello world or something like that, and we start giving it traffic. Very nice. You got your hello world going. Now some manager's going to come, usually saying, there's a fire, you actually need to create an application right now for this. You'll sort of do what you can about it, but then you have to deploy the application you just created. When you go, you create a deployment. This creates a new ASG, the auto-scaling group. They create a new one. It creates a new set of instances for this new deployment, and it downloads the containers for your new version into these ASG instances. Once you get all of that, we start the log systems, we start the metrics, and we progressively start switching the traffic from the old ASG instances into the new ones. Why is this done? Because we mess up a lot. So the idea was, OK, when you're messing up, we'll just switch the traffic, and all of the instances are running and ready to receive the traffic of all of your angry users saying, why am I seeing a 400 error? And if everything's OK, you just say, yay, congratulations to me, you open up a beer, and all of the ASG and instances of the other side are destroyed. This is what we've been working on the last time. We're progressively switching into this infrastructure or into this platform. But what I wanted to say here before closing the talk is that this is not necessarily the best architecture, or especially it wouldn't have been the best architecture for us to start with. This means all of the tools I've been talking about, they're really cool, but they took a long time to develop, a lot of effort. And I think it's important to create the tools you need for your own organization. And the one thing I do think we started really on the wrong side, and we found out later, was empower your developers. They need to be able to do everything. If you actually have bottlenecks, even if you think, but it's networking, it has to be done by some person, empower your developers. You'll be amazed at all of the stuff they can do and how that actually can scale. And try to apply that logic into anything. Just empower people and give them tools and see what happens. At least for us, it's worked. So, well, that's been our history. This is where we're now. Well, that's it. I don't know if we have time for questions or not, but otherwise, thank you very much for all the time, all the attention. I'll probably be at the Mercado Libre booth tomorrow. I think we don't have a lot of time today, in case anyone has any more questions.